What is up, everyone? So, another day, another Leetcode. So I'm going to be doing post-order traversal. As you guys know, I've done in-order and pre-order. So, without even having to look at this, I'm going to try and solve this question using the exact same logic I did in the previous two questions. So, let's get this on the road. So if the root node is none, I want to return an empty array. So like so, if root dot left and equals none and root dot right equals none, return this with root dot val. Okay, so now I have my base cases, which basically fixes example 2 and example 1. The next thing I'm going to do is create an array. I want to track these traversals. The next thing I want to do is create a helper function. So def post trav helper self. So I'm defining it within the scope of this class. I have to add self. The next thing I'm going to do is add the root or add the node that I want to traverse and an array that I want to traverse. Then I return said array. Actually, don't return the array. I only return my base case because I have my array here. I'm going to link it to this function, and this function is going to traverse and add to this array as we traverse until it hits the base case that comes back. So what we're going to do next is return the array, because this is the final result I'm looking for, and then call my post trav helper. I'm going to feed this the root node. I'm going to feed this the array that I have here. So now I'm linking it to this. So now I call it within itself. It's going to go here. Then I'm going to have to create a base case for this to end. So for this to return back the call stack so it doesn't go on forever. So if root or if node equals none, return. That means this is done. Then I'm going to get array. So this is what? Post order traversal. Okay, so first I want to traverse, then add elements to my array. So I'm going to traverse. Node dot left. I'm going to call it on itself to the left node. Post trav helper boom node dot left array. Then I'm going to go node dot right. If there's a node dot right after, self dot post trav helper node dot right array. Then I'm going to do the part of the code where I add to array. So in the pre-order, so I'm going to take this. First I'm going to go array dot append node dot val. So first what I'm going to do is, this is for post order because I want to explore first, then do the check. If I wanted to do it as a pre-order, Control X, cut, I would put it here. Exact same logic. If I wanted to make it an in order, I would do this. So it's all the same logic for all three. It's just the order of execution that changes. That's all I want you guys to take away from this video, because we've already gone through the concept of traversing a binary tree in pre and in order. Now we're just doing it again in post order. All we've done is use the exact same logic, and we're going to change the order of execution to change the order of the array that we get as our output. So let's run this. Accepted, submit it. And Bob is your uncle. Well, he's not my uncle, he might be yours. But yeah, we're done this problem. It beats 28.12% of solvers, and same way we did the other two questions. So like I said, once you recognize these patterns, once you recognize how to solve these patterns and these algorithm questions, it becomes really simple. You can just apply what you've learned to the next problem, or you can apply the concept of one problem to another problem, or you can take an in-order traversal, stick it in another problem that you might have to use, and then add on your own logic, and then create your unique solution to the problem, right? So all this stuff builds on each other. All this stuff is repetitive. All you do with these questions now is just take what you know and modify it. Modify it to the needs of the requirements, the constraints, whatever you can do to get from A to B, right? So if you like that video, please give it a thumbs up. Subscribe to the channel, leave your comments in the comment section below. I'd love to hear from you guys. And that's it. Happy coding. Knologist out.